Good morning, students. We will try to discuss the basic modes of heat transfer. The three types of heat transfer are the conduction, convection, and radiations. So, before going to this three basic concepts related to the conduction, convection, and radiation, we will try to see the difference between the thermodynamics and heat transfer, what it offers from the different two domains here. So the transfer and conversion of energy from one form to another is the basic to all heat transfer process, and hence they are governed by uh, the first law as well as the second law of thermodynamics here. This does not and must not mean that the principles governing the heat transfer of heat can be derived or from mere corollaries of the basic law of thermodynamics. The major difference between the thermodynamics and heat transfer is the foremost is that um, thermodynamics deals with the relationship between heat and other forms of energy here, whereas the heat transfer deals with the analysis of the rate of heat transfer here. So thermodynamics primarily deals with the energy transfer to change the system from one equilibrium state to the another. However, it cannot tell the duration for which the heat has to flow to change to that state of equilibrium. But in case of heat transfer, uh, the form of energy that can be transferred from one system to another system is due to primarily the temperature difference here. So determination of rate of such energy transfer forms the basis in the heat transfer here. This is the basic difference between the thermodynamics and heat transfer here. So first we will try to see what is the conduction mode of heat transfer. The conduction mode of heat transfer primarily occurs in the solids, and the famous law which governs the conduction mode of heat transfer is the Fourier's law of heat conduction, which is given by the equation Q is equal to Ka delta T by X, where K stands for the thermal conductivity of the material. Thermal conductivity is defined as the ability of the material to conduct heat, and A is the heat transfer area measured in the normal to the direction of heat flow, and delta T is the temperature difference at the respective ends. So always keep it in mind that the heat transfer will take place from high temperature source to the or high temperature surface to the low temperature surface, and del X stands for the thickness of the material here. So without temperature difference, the heat transfer may not take place in conduction or in convection or even in the radiation here. So in solids, the heat transfer is due to the combination of vibrations of the molecules in a lattice, and energy transport is by purely by the number of free electrons present in the outermost shell. Whereas in the gases and liquids, conduction is due to the collisions and diffusion of the molecules during their random motion here. So by this principle, the heat transfer takes place in the solids as well as in the gases and liquids here. Coming to the next mode of heat transfer, it is the convection heat transfer. So heat transfer by convection takes place between a surface and a moving fluid, or or a moving surface or a stationary fluid. The sufficient delta T should be present between the fluid and the surface. Then only the convection mode of heat transfer takes place between the respective surface and the fluid here. So two mechanisms are involved in the convection. One is the first is the transfer of energy due to the random molecular motion, that is purely by the diffusion process. Second is by the energy transfer by bulk or macroscopic motion of the liquid. So we have two types of convection. One is the natural convection, another one is the forced convection here. So in natural convection, the fluid motion is set up by the buoyancy effects resulting from the density difference caused by the temperature difference. So as we know that when air gets heated, it gets lighter and it moves in the upward direction, and the space will be occupied by the denser air. So this is an example shown in this picture here. So periodically the cold air will try to occupy the space which is left out by the hot air. Whereas in the forced convection, the fluid motion is artificially induced by a pump, a fan, or a blower that forces the liquid over a surface or over a flow. These are the references we have seen. We will continue to